Okay, this is your post lab, and we are going to start this by looking at our first substance, H2S. I ask you number of valence electrons, and this will be hydrogen has 2, which is 1 times 1, or 2 times 1, plus sulfur has 6 for a total of 8. 8 valence electrons. When we write our structural formula, we should start by writing our first substance. I'm doing electron dot first. Sorry about that. I should start with my S, and I'm going to do 1, 2, 3, 4, 5, and 6. Next, I'm going to add my 2 hydrogens here and here. I could draw this one of 2 ways. I could draw it like this, or I could draw it like this. They're both correct. It's easier to see that my shape is bent with the second drawing. But even if I don't see that, I can see that I have 2 unshared pairs of electrons there and there. And that means that my electron geometry is tetrahedral, and I have 2 pairs. This is so ugly. Let me write this up here. I have tetrahedral with 4 electron domains and 2 bonds. So a 4 and 2 gives me a bent shape. My polarity, I'm just going to write polar and nonpolar. This is polar. My intermolecular attractions, since this is polar, it can be either dipole-dipole or hydrogen bonding. This has to be dipole-dipole because hydrogen bonding has to be with N or F. So be careful, this is not linear. And a lot of people write it down as linear. Next, P and H. P has 5 valence electrons, and each H has 3, for 1 times 3 will be 8 valence electrons. So P has 1, 2, 3, 4, 5. Each H has 1. So my structural formula will be and if I look for my shapes on this will be trigonal, pyramidal. Make sure you look carefully. It is polar, and it will also be dipole-dipole. I'm going to go ahead and write my polarity up here, and I'll do that with green. This is my delta minus end. This is my delta plus end. The unshared pair of electrons that you see right here is always the delta minus. Next, I have silicon tetrahydride. And silicon tetrahydride, silicon has 4 valence electrons, and hydrogen has 4 times 1 equals 8 valence electrons. Silicon has 1, 2, 3, 4 valence electrons. Each of the hydrogens will bond, and I'll have Si, H, 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 and H. This is a regular tetrahedron, so it's not polar. Already gave this away. This is tetrahedral. And if it's nonpolar, the only intermolecular force at play will be London dispersion force, LDF. Sorry, I ran out of room there. So you should have sort of a, should be getting the hang of this one right now. I'm going to do SO2. SO2 has 6 plus 6 plus 6, or 18 valence electrons. If I do my math on this one, I'm going to give myself some room and do my math right here. I'm going to have 3 times 8 equals 24 minus 3 times 6 is 18 equals 6 divided by 2 equals 3. So I need to have 3 bonds. Since S is in the central, I'm going to do this one first. S, I'm going to have a double bond and a single bond, and then an O and an O. It's a little easier to see over here. This will be S, double bond O, bond O. And it will be, this is a resonance structure because my double bond can also be on that side. This is polar. My shape for this will be bent, and this will be dipole-dipole. So this is in general how you do this side. Let me go up to the top and see what else I have here. Identify, give the geometric shape. Okay, for each of these substances. So basically, the only two that you have to do on your own are these, and I did this one in class. So this is like the only one you need to do on your own. Now I'm going to go to the last page. These are all polyatomic ions. I'm going to tell you that this has resonance and this has resonance, and this one is hard. And you can find, I would like you to do one with a triple bond. Well, I don't care what you do, I guess. There's 3 different ways to do this. So give it a shot and see if you can figure it out. So these will all need to have brackets. So your valence electrons will be N equals 5 times 1. H equals 1 times 4 plus 1 extra will be 10 valence electrons. Oh, that's got a plus, so that's going to be minus 1. My bad. I was going to say I can't have 10. And it'll be minus, that equals 9, and it'll be minus 1 because it's a plus charge, will be 8 valence electrons. 1. And you don't have to do electron dots for this one. I guess you do have to do electron dots. For polyatomics, you need to put them in brackets and put the charge. Let me do, I think I did. I showed you this one in a PowerPoint. That had resonance. And this one you can skip today if you want. I don't know, you might have another one. I think you have more on yours. Question mark, question mark. I don't remember if you do or not, but we'll talk about those later. So that should help you do your labs.